right, so the knowledge test is going to ask you lots of questions. A bit of them are concerning navigation using the VOR system. I don't have a lot of navigation type questions with satellite-based navigation, so we are sticking with our ground-based systems. We will be looking a little bit at bearing pointer as well. I'm also going to focus in on the VOR. We're going to be looking at making sure that we can understand when we talk about a radial or a course, we understand those terms today, understand about intercepting, right? And then go over some of the types of problems the FAA is going to give you on the knowledge exam as well. And then we should have time for another group activity. We'll see on that. So getting started here, we're going to begin our discussion on the very high frequency omni range system, the VOR. VOR used to be the backbone for navigation, point A to point B. It is being reduced down to a minimum operational network status. So effectively, over the next couple of years, we're going to see most of the VORs get closed down. I did hear a rumor that we're losing Litchfield in March this month. Don't know yet, but it's just a rumor. So these things are going to be happening. Minimum operational network, just if you're not familiar with it, is going to involve any VOR system that's required for an ILS approach, and then a couple other key VOR systems around the country. So there's going to be a drastic reduction. In our area, the closest VOR will be Victory. So it's part of the ILS system up in Grand Rapids. And then over Detroit, they'll have one. I think it's going to be Carleton. So there's not going to be a lot left around here. But keep in mind, the FAA is still going to ask you questions about the VOR system. So make sure you're up to speed on that. So let's get started and just go back to a couple of the basics here. Got a discussion page. If you got some questions there, making sure you understand the concept of the radial. A radial is a directional signal. It radiates from the station. So always try to remember that radials radiate from. So in other words, if I was to be at the station and walk in a direction of, say, 060 degrees, I would be on the radial 060. Or if I'm at station, got my back to the station and I start walking 280 degrees, I'm on the radial 280. Radials radiate from the station. So it should be a very easy concept going from a station. Let's take a peek at Top Hat here with some questions on radials. Make sure you understand the concept here. If you completed assignment D2, this should be quite easy for you. You're going to use the outer edge of the compass rose and click on radial 300. This is one of those touch point questions. Click on the outer edge of the compass rose on radial 300. All right, so most of you understood it. Most of you understood the directions too. So the directions were to click on the compass rose, okay? So some of you didn't get quite on the compass rose right there, okay? Or this one over here. Some of you did radial 120. So radials radiate from. Put your back to the station, face 300 degrees. Start walking. That's a radial that you're on. Looks like someone did 330 by mistake up there. Let's try another one. All right. It's going to be same instructions, but radial 045. These type of questions should not be a struggle bus for you, right? It should be just click and go. All right. Yeah, awesome. You got it. All right. So let's talk about the reciprocal now to the radial. Remember, radials radiate from the station. And so there's always another course on the opposite side of that radial. And if I think of the radial from the station as a from course, I can think of its reciprocal, the one in blue there, as the same number, but the to course, which divides this system, the station, up into two distinct areas, a from side as well as a to side. So anytime we think about a radial, it has a reciprocal, which is a to course that will take you to the station. So I always think a 360 from course, my back is to the station, I'm facing 360 degrees. On the to course, I'm facing 360 degrees, but I'm going to the station. That's how I like to think about it, get my orientation. Now, what happens if I change the course? I've been using 360 here. What if I go to course 090? Well, everything rotates then with it. The to side and the from side rotate. So there's a bisector line, you can see, runs perpendicular through the station and the course that bisects this into two spheres. Again, a 090 from course, I'm facing 090, I'm going from the station, which puts me technically on the east side of the station there. If I'm facing 090 on the west side, I'm going to end up going right to the station. And just another example, if I change it one more time, my course of 210, to side and the from side does change on that. Of course, now this is a little different concept than the VOR, I'm sorry, than the satellite-based navigation, which is always a to navigation system. Okay? But with the VOR, we have the ability to fly over the station on a course from it. So let's try a top hat question, see if you understand reciprocals right here. Again, use the outer edge of the compass rose, click on the reciprocal of radial 300. Remember, if radials radiate from the station, then the reciprocal is the to course. So where would I be if I'm facing 300 degrees but going to the station? All right, most of you got that one right. Yep. Looks like someone put 150 down and someone else put 110 down. Or no, that's 105, sorry. So most of you got that one correct. Try one more. reciprocal of radial 045. All right, yep, most of you got that one correct, 225 on the compass rose at the reciprocal of 045. Different ways to think about reciprocals. Some people like to add or subtract to 180. Your human calculator, not a problem. Some of you like to do a 200 plus or minus 20 to get it down. I think of it as if 45 degrees is to the right side of the north side, clockwise, then I have to go 45 degrees clockwise of south. Doesn't involve much math that way. So just different methods to get a reciprocal. In addition to the two side and the from side, we break this up further into quadrants. The to and the from being a portion of the quadrant information. We also have a course deviation indicator. And your equipment in the aircraft tells you how far away you are from the course. So if we are looking at course 360 from, because that's what my equipment has down here, 360 from, the CDI needle, remember, is just a representation of that actual course line. And so if you're on the actual course line, in other words, you're on this 360 radial here, then you have that centered needle. Right? All this information must match. So if you are trying to reference radial 360 on the station here, your equipment has to be set up for a course 360, and it has to have that from indication there. If you had a different indication on here, you would be getting some different results. It works in the same principle for the to side. Okay? So now we switch down to 3602, the station down here. Okay? Courses still must match. Otherwise, we won't be in the right position around the station. All right, so try another top hat question here. Using the outer edge of the compass rose and clicking on the 0902 course. You got to think. Just picture yourself heading 090 degrees and going to the station. Which means you're going to arrive at station on a 090 heading. All right, most of you got that one correct. A couple of you chose the east side of station. Remember, if you're facing 090 and you're on the east side, that's the from course to it. Try one more of those. Click on the 120 from course. So if I'm facing 120 degrees, where would I be from the station? So station's to my back. All right, most of you got that one correct there. Looks like about 3 of you chose the northwest side of the station. If you were on the northwest side facing 120, you're going to the station. Let's look at this CDI deflection just a little bit more to see how this breaks this up into different quadrants. The deflection of that course needle does indicate which side of course that we are on. So in other words, if my needle is in the centered position, we know I'm on the course line. Okay? And without an indication of a to or a from, we don't know on the to or the from side, but we know we're on this course line somewhere. We know that. Okay? By adding in a needle, by adding into a needle deflection, say to the right side on your display, that puts us in this orange right needle area. So the concept that they decided early on when they developed the VOR system back in the 40s, the 1940s, was if you're going generally in the direction of your course, in other words, if I'm flying a heading of somewhere around 360 degrees, all I have to do is follow the needle. The needle to the right, I need to turn right. So my airplane would be somewhere in this type of area here, and you can see both cases would involve the right turn. It's kind of simple concept that they decided to implement. But there's the big if, you know, if you're going actually within 90 degrees of that heading, you'll get that normal sensing. If you decide to try and turn your heading around, go the opposite way, you'll get what we call reverse sensing on that. Okay. So a left needle deflection gives you an indication in the blue area here. So an airplane perhaps would be in an area where it's just simply turning to the left. Left needle deflection, turn left. Now, I personally don't like turning left and right per se. I like directions better. Right? And later in class, I'll teach you about how I can make a heading to get to a course within 5 seconds. Okay? So I'll get you all taught up on that. When you twist your course in, let's say you go to a 090 course. I know that because at the top here is my new course. Right? Not only did our to side and from side change, but where the left needle and the right needle deflection areas are, that also changed. So any sort of a left needle means that we are now on the northern side of the station. We got to go in a southerly direction. And if you were flying on that easterly direction, then you can easily see it's a right turn to get back to the course. And very similar for a left needle deflection. That puts you in on the south side or the southerly side. You could be southeast, southwest. But if you're going 090 degrees, a left turn gets you back to course. I think of it as a go northerly to get on course. And one more example, if I flipped it all around the 210 course, everything still flips around, right? I still have my to side. I still got my from side. Everything just flips around with it. Right needle area, it's still on the quote left side of the course line. So let's try top hat question, see if you understand the concept here. I'm going to determine the relative position of the airplane. Okay, so multiple choice question. Okay. I didn't give you a to or a from. Okay, I give you 180 degrees and left course needle. So you can think of it, if I'm flying 180 degrees and I have a left needle deflection, which way do I got to go to get to the course line. And that will help you determine what's your position about the VOR. Give you a few more seconds here. We'll see how you did. Okay. Looks like most of you got that one correct. But I bet for a lot of you, you just struggled with that. It's like, oh, now I got to think of myself going this direction. And I'm all turned around now. So there's got to be an easier way to do all this. And there is. All right. Let's just kind of show you the representation here. This is what it looks like. But we're in this nice ground school setting, so we can draw things out all day long, and we can figure this out very easily. I tell you, my little trick here, though, is always to start at the center, move out towards the CDI, and I find whatever number is over here. Got to go east. Do that in 5 seconds. Right? It's my little trick. We'll touch on that a little bit later. Looking a little bit more at your VOR display. You have to remember the VOR is made up of 2 signals. One signal is an omni signal, so just like any sort of broadcast antenna, it just sends out a signal in every single direction. And then a second signal is sent out, but this one is very much directional. And we think of the example of a lighthouse, where the light is shining in one direction and it rotates all the way around the full circle. That's the example of our second signal there. And then we simply compare the 2 different sine waves that come off those signals, and we discovered the phase difference between those 2 signals. Your equipment on board is simply going to determine that phase difference and determine I'm on such and such of a radial or course, and it figures out, am I on the to side or am I on the from side, depending on what you have set in for a course over here. Okay. And then it tells the course deviation indicator what to do. Okay. Looks like my circle's a little light over here. Just draw it in a little bit for you. I gotta change my graphic. All right, so there's your display in the cockpit there. 360 course. I'm thinking about the 360 from course, right? Then I would have a from indication down here. Okay. But my scaling, though, the important thing here is we know automatically from our center position to the last dot is 10 degrees for VOR scaling. Doesn't matter how many dots you have in between. Sometimes you have several dots in between, sometimes there's 1 dot in between. It's always going to be a 10-degree deflection for you. And that would represent, think of a triangle. Remember last time we met, we talked about 1 degree. 60 miles out is 1 nautical mile wide, the 1 in 60 rule. So your area for where you're getting that signal fans out like that triangle there. You might be able to understand that if you're close to the station, the needle will move quickly. If you're far from the station, your CDI needle will move a lot more slowly. And then we also have, looking at this display, only has 1 dot in between full scale and 0, so that would be its half scale deflection. So it's going to be important to remember for some of the FA test questions. Full scale is at 10 degrees. Given a from indication, then we're looking at the from area, and we can then determine the quality of our tracking. And certain certain tests on the ACS indicate you have to have a certain scaling or less for your tolerance on that. All right, so we're understanding this display. We understand full scale now is 10 degrees. If I add in a little bit more information here and put a right needle deflection in, this is my right needle area. And when we talk about quadrants with a from indication and with a right needle deflection, this becomes the quadrant that the airplane is located in. So if I had something that was beyond full scale deflection, I am outside of this triangular area right now. Once my needle deflection moves to that dot there, I'm on this little dashed line that I just drew. So this will be important to understand for some of the FA test questions later. Try to top that question here. Looking at CDI displacement in degrees. So look at the display and determine how many degrees of CDI displacement there are. That should be a real quick one for you. All right. Whoa, okay, that's a big surprise there. Only 48 if you got that one right. So that last dot there, or let's start with the big dot, the big circle. Sometimes I call that the donut. That's our 0 point. We're on course. Right. The last dot is a 10-degree deflection. So halfway in between those two is one dot. Yes, question.
I don't know if this affects the numbers, but I've entered in 5 and it has a check box and everything.
Really? Wow.
Yeah,
I don't know if it does that, but if you go to the grade book, it would be fine.
So I'm seeing 48 of you did answer 5. So that's an interesting thing. I'm not sure why Top Hat is doing that. I don't get to see that. But if you did answer 5, you did get it correct, so no worries there. So again, that last dot is 10 degrees. So if your CDI is on that last dot, that is 10 degrees. All right, let's see if we can try another one. CDI displacement in degrees. All right, wow, 10. That's a lot better. Okay. Try one more. Multiple choice here. Your needle's gone past the 10-degree mark. All right, more than 10 degrees. So that last dot does represent 10 degrees. If your CDI is beyond it, you are then more than 10 degrees. But we don't know how much. It could be 20 degrees off. You could be 30 degrees off. It could be 60 degrees off. You could be 80 degrees off that course line. You could be all the way up to 89 degrees from that course line. And we just don't know how far away we are. That is a limitation of the VOR system. If you're not within 10 degrees of the course line, you don't know how close you are. All right, see if you got any questions. Move back to our slide. No questions typed in there. Any verbal questions? All right, wonderful. We'll tell you what, go ahead, take your first break, take about a 5-minute break, and then we'll come on back and get some more of this done.